Hey, hi everybody. You did it. It's Thursday, last day of the week for you, and we've made it through new information about circles, and we're going to continue in that vein today. Our target is to investigate quadrilaterals that fit in a circle, and we want to prove using our words and other representations properties of angles for a quadrilateral that is inscribed in a circle. Our assignment for the day will be cumulative review, day 4 worksheet, and all that information is located in Google Classroom, so please make sure that you do get connected to Google Classroom and get that assignment. Also, please don't forget that there is the Delta Math 10 problems for you to do that are helping you to just support your information and learning about the inscribed and central angle relationship. So please make sure you get that done. It doesn't take very long, so get that done before Friday. Thanks. Our lesson again is Unit 4, and we're still working with circles. Today is December the 5th, and we're just going to move on. You should have a worksheet, activity sheet that has some figures on it, front and back, and then you'll be getting a little cool down a little bit later on that needs to be completed and turned in today. If you do have any homework assignments that you want to turn in, please turn them in your classroom basket, the box that has your class number 1, 2, 5, or 7 on it. Again, today, December the 5th, we're looking at circumscribed quadrilaterals, and we're going to prove a couple of things here, that properties of angles for a quadrilateral inscribed in a circle. We're going to prove some properties there, and we're also going to prove a theorem about opposite angles in quadrilaterals that are inscribed in circles. The first thing we need to do today is connect the dots. This should take you about 4 or 5 minutes, and there are 3 quadrilaterals that are pictured on your activity sheet. For each of these, please use a compass to see if you can draw a circle that passes through all 4 of the vertices on the quadrilateral. So the circle that you draw needs to contain all 4 points. And give you a few minutes to see if you can get that done, and then you please pause the video and come back when you're ready to move on. Hopefully you've finished and found that, hey, it works. Well, for a couple of them anyway. I had a little problem with the third one, wasn't able to try to actually get all 4 of the vertices, but we could at best get 3, and if that's how you did that, that's great. You did it absolutely correctly. There are 2 new terms we need to take a look at. A circle is said to be circumscribed about a polygon if all the vertices of the polygon lie on the circle. And if it is possible to draw a circumscribed circle for a quadrilateral, then the figure, that quadrilateral, has a special name. It's called a cyclic quadrilateral. So please pause the video if you need to and write those 2 definitions in your notebook. Okay, next we're going to look at some more inscribed angles and circumscribed circles. We've seen that some of our quadrilaterals have circumscribed circles, but others don't. We're particularly interested in those ones that are cyclic and the ones that do have circumscribed circles. So take a look at these images that we have on the screen right now. You do have them on your activity page as well, and I want you to do a couple things with them. First of all, for each of the 3 figures, notice that their quadrilaterals are all marked with the same letters, P, Q, R, S. And in each case, we're going to highlight the arc that extends from S to Q, and we want the one that's passing through point P. So you want to start at S, and use either a highlighter, you can use a colored pencil, and highlight from S all the way to Q, going through the letter P. And then find the measure. Find the measure of that arc that you just highlighted. Once you've found that, then use the information you have to find the measure of the other arc that goes from S to Q. That one will actually go through point R, but find the measure of that one as well. And then once you've done that, use the information you know and find the measure of angle SPQ. Again, focusing on the knowledge that you have about inscribed angles and circumscribed circles. And what you should have highlighted with your picture is something similar to what's on the screen now. You should have that the green, the highlighted, what I have highlighted in green would be the first arc that you were asked, going from S to Q through point P in each case. And then the measure of those arcs are twice the measure of the inscribed angle. The arc that is intercepted, we say the arc is intercepted by the inscribed angle, and that arc is always twice the measure of its inscribed angle. So the arc is bigger measure-wise than the angle, and we see then that for the first one here, that it's 210 degrees. That arc is 210 degrees. So that means the other arc, the one that's going from S to Q through R, that one needs to be the difference between our 210 and 360 degrees, because we know that a circle measures 360 degrees in total, going all the way around. So if part of it's 210, the other part has to be 150 degrees. And then angle QPS, that angle for the first example would be half of the arc that it's intercepting. So that would be 75 degrees. And please check your numbers for the other two. Make sure that you got those correct and you understand what we're doing there. Now, earlier in the week I told you that we were going to start using the Greek letters alpha, beta, theta, maybe delta. Today is where we're starting this, looking at this other quadrilateral CDEF, and we have two angle measures that are given, alpha and beta, and the question that we have is, what's the value when you add those two together? What are you going to get? What number are you going to get? Again, the alpha and the beta are representing measures, they're representing numbers, and then explain or show how you know that to be true. And you can work together on this and come up with an answer. Write it on your activity sheet, if you will, please. Okay, hopefully you found that those two angles, alpha and beta, those measures, equal 180 degrees. And we should know that the opposite angles of a quadrilateral must be supplementary in order for the quadrilateral to be circumscribed with a circle, with a circle going through all those vertices. So they have to, the opposite angles have to be supplementary, have to equal 180 degrees. And let's look at those three quadrilaterals that we started today with. And what do you notice about them? And what do you wonder? Okay, quadrilateral ABCD is a cyclic quadrilateral. Again, that means that there is a circle that will be formed with a center and will go through the center. The circle will go through points A, B, C, and D. with this figure, and it's on your activity sheet, please draw the diagonal BD, and then answer a few questions that we have listed here. We want to know, how will this diagonal relate to the circumscribed circle? What is special about that diagonal? And please do explain your reasoning. You can work on with your shoulder partner here, or work at your table to explain and discuss what is special about diagonal BD. Once you've got that figured out, construct the center of the circumscribed circle for the quadrilateral ABCD and label that point O. And then please explain why your method is actually going to work here. Finally, we need to construct the circumscribed circle and ask ourselves, can we use this same process or procedure for any cyclic quadrilateral? And then if it is possible, why is it possible? Explain. And so here I have that drawn for you, and BD, as you note, is actually extending from one side of the circle to the other side of the circle, going through the center. This we call a diameter. That is a diameter, and as some of you had said earlier in the week, well, this O is the midpoint, and you're correct. It is the midpoint of that diameter. It's the center of the circle, but it is the midpoint of the diameter. So very good. And this is how you should have your construction when it is completed. So BD is a diameter, and we find O by just finding the midpoint of BD, and then that's going to be the center of our circle. So synthesizing this, putting it all together, how do the distances AO, BO, CO, and DO compare? Take a minute or so and just talk to each other. So what's special about those segments? What do we call them? And then, using the information, let's take a look at this quadrilateral CDEF and the diagram, the information they're sharing with us. Would this be considered a cyclic quadrilateral? And how do we know? Take a couple minutes and talk with your shoulder partner about this, with the people at your table. Would it work? And here's another quadrilateral, and in this case, each vertex is representing a town. We have a construction company that's saying it is planning to build a shopping center, a shopping mall, and it's planned to be the same distance from each town. So no town is getting special treatment here. They're all getting the same distance to the shopping mall. But our friend Claire says, hey, this is impossible. Is she right? And how does she know? If she is right, how does she know that that it's impossible? Take a couple minutes and share with your partner, think through this, and let me know, is Claire right or is she wrong? And how do we know? Now you should have a little sheet that is your cool down. This is something I need you to complete. Find the measures of angles CFE and DEF. Write them on the paper, show all your work, make sure your name is on the paper, and then this does need to be turned in either to the box that has your class period labeled on it, 1, 2, 5, or 7, or you can turn them into the sub and I will get them on Friday. Now I won't see you guys until Monday, but I will still be at school tomorrow or Friday, and we'll pick up any papers that you have there. So Again, your assignment is cumulative practice day 4. Aw, yeah, you can do this. About 5-6 questions is all that's listed on that one. So please do get that done, and also don't forget you have the Delta math assignment that is online. Get her done quickly so we can get those grades put in. Hope you have a great weekend, and we'll see you on Monday.